Number 1, integral 1 to 3 okay, so you want to integrate. So this would be 3x to the third over 3 minus 4x squared over 2. Running it from 1 to 3. 3 over 3's cancel. 4 over 2 is 2x squared from 3 to 1. So you're going to plug in 3. We're going to plug in 1. You're going to subtract them. So if you plug in 3, you have 27 minus, plugging in 3 here is what? 3 squared, 9, 18. Minus, plug in 1. 1 to the third's 1, minus 2, so minus 1. We got 9 minus a negative 1. Final answer 10. Okay, for number 2, they want you to find the derivative. I don't have the directions written here, but on your packet it says find the derivative. So to do that, you need a product rule. You have 2 things. You have 1, you have 2. Set up 1, 2, 3, 4. Say again?
Is that you?
You don't need a u substitution. We're not integrating, we're taking the derivative.
Not me. Is that you?
You.
Like, oh, you.
He's doing this right now. He's
Why?
doing this right now. He's recording this.
I'm going to keep going. All right. So we keep the first, derive the second. So you want to rewrite this. Think of this thing as what? 4x minus 1 to the 1/2.
You're gonna have a bunch of little, so you're gonna have a chain rule. Yeah, chain
Need a chain rule, right? So 1/2, 4x minus 1, drop the power by 1, so negative 1/2. Got a 4. Other way around, you keep the stuff in the bracket. X becomes a 1. Make sense?
Yeah.
All right. So the x and the 4 combine. The 2's on the bottom, and this whole root's dropping to the bottom. 4x over 2 root. 4x minus 1 plus, this times that stays. 4x minus 1. Good answer, but it's not going to be the one on the multiple choice there, so we need to combine these. 4 over 2. So I have a 2. This is really over 1. If you want to add them, you need a common denominator, so this is missing over here the what? Square root of 4x minus 1. So if I give this the square root of 4x minus 1, I need to put the same thing on top, which really makes that quantity squared. So now we have 2x plus, and the root would go away, 4x minus 1, put quotes there, 2x and 4x, 6x minus 1 over square root of 4x minus 1. Make sense? Okay. If g of x is equal to that stuff, it's the integral of g of x. They're giving you the result of g of x. They say, if I don't know what g of x is, but it says if I was to integrate this thing, here's my result. And then they want you to find g of x plus 7. So we can split this into 2 different integrals. One is a, b, g of x. It's adding, so plus integral a, b, 7. Okay. I don't know again what this is, but I don't need to because they already gave me the result of this one's integral, right? This one is 4a plus b. The second one, bless you. If I integrate 7, 7 goes to what? 7 would turn into 7x from a to b. So plug each of them in. This is 7b minus 7a. Do a little more math. What do we have? 4a minus 7a is minus 3a. And b and 7b is 8b minus 3a, choice C. Sarah. You sure?
Yeah, I just struggle with the wrong answer.
Does this make sense though? Number 4, f of x is equal to this equation, find f prime of -1. Before you find the derivative, rewrite the original. So we're going to say the original is equal to negative x to the 5th plus x plus, I'm going to rewrite 1 over x squared and call this x to the -2. Now I want to take its derivative, so f prime of x is equal to negative 5x to the 4th plus 1. The 2 is going to come out front, and it's a negative, so this would be minus 2x to the, dropping it by 1, so it's the -3rd power. Before I plug in what I was looking for up here, I'm going to rewrite f prime of x and say f prime of x is equal to negative 5x to the 4th plus 1 minus 2 over x to the 3rd. Now I have my exponent back to being positive, and we can plug in. F prime of -1 is equal to negative 5x to the 4th plus 1. I didn't plug in -1. Let's try that. -1 minus 2 over -1 to the 3rd. -1 to the 4th stays at 1. So -5 times 1 is -5 plus 1. And here's where we have to be careful right over here. I have -2 over, what do we got? -1 to the 3rd is still a negative. So I have a negative over a negative, which really gives me a positive. -5 plus 3, -2. Good? Okay, given this equation, we want to figure out where it is concave down. If I want to talk about concavity, I need to find which derivative.
The acceleration,
Second derivative. So currently I don't even have the first one, so I want to start with saying the first derivative is equal to 20x to the 3rd minus 72x squared plus 48x. Second derivative would be 60x squared minus 144x plus 48. Now I have the second derivative. I want to set it equal to 0. While I'm doing that, you know once you set it to 0, we're going to need to find these inflection points. I'm going to say, is this divisible by anything to make my factoring easier? 60, 144, and 48 all divisible by 12. Okay, so I'm going to say 12. And if I pull that 12 out, what does that leave me? 5x squared minus 12x plus 4 is equal to 0. So I'm going to take this part in the middle and I'm going to try to factor it. First times first, 5 is a prime number, so 5x and x. Trying to create 12 in the middle. Last number is positive, so I'm going to say negative, negative. Set them each to 0. If I set this one to 0, I've got 2/5. I set this one to 0, I've got 2. So we want to know where it's concave down, so we need to do second derivative test. We want to make a number line. Here's 2/5. Here's 2. I'm going to pick numbers between them. To the left of 2/5, we'd pick, you can pick anything you want. I'm just going to go with 0 because that's easy to plug in. Between 2/5 and 2, let's pick 1. To the right of 2, I'm going to pick 10. Again, any numbers that fit that interval is fine. And I'm going to plug them into the second derivative, which is right here. So, if I plug in 0, 0, 0, I get positive. If I plug in 1, what do we have? 60, that'd be the 60, right? This is 48, so 108 minus, this one would be negative. Plug in 10, you're going to get positive. Back to the question, number 5. It says we want concave down. So I want the interval from what? 2/5 to 2, and that would be choice E. Make sense? Number 6 asks for the integral with a 1/3 out front, e to the t over 3 dt. Need a u substitution. So I'm going to say let u be equal to, I'm going to call it 1/3 t. For me, that's easier to see that as a derivative. 1/3 t or t over 3 mean the same thing, right? So du is equal to what? 1/3 dt means dt is equal to, how would I undo this? Multiply by 3. So it's equal to 3 du. So I take this stuff now and I plug in. So I have 1/3 e to the u, dt is 3 du. We take this 3 now and we pull it out, but there's already a 1/3 on the outside. So 1/3 times 3 is going to go away. Now you have the integral of e to the u du. E to the u, when you integrate, gives you e to the u plus c. And what was my u? E to the 1/3 t. Let's put it back into the way they had it though. T over 3 plus c. And that is choice C. All right, number 7, d dx cosine to the 3rd power x squared. Before we do anything, we want to rewrite this problem in a way that makes more sense. So I'm trying to find d dx of cosine x squared, all of that to the 3rd power. So when you rewrite it, it shows you need a chain rule. So we're going to say 3 cosine x squared. I'm going to drop the power down by 1 and then multiply by now the derivative of what's inside for the chain rule. Cosine goes to, not sign, but negative sign. So I'm going to put my negative symbol out front because I'm multiplying, right? So sine of x squared, and then what else needs one more? 2x. So that is correct. They're going to combine some stuff here, though, for the one you're looking for. That one and that one are going to combine. So you'd be looking for negative 6x. And notice how they always write their to a power in between here. So it's cosine squared x squared, which means the same thing as this, but this is how it's written. And then sine x squared. Good? Okay, number 8, I'm going to try to hold the graph up here so we can see it. You have it in front of you. It says a spider begins to crawl up a vertical blade of grass at time equals 0. What's the key to this? It says, when does he change direction? When you have a velocity time graph, it changes direction, whatever it's talking about, whenever your velocity goes from positive to negative. So if that's the graph of velocity, you would change direction wherever the velocity becomes what? 0. So in this case, it would happen at t is equal to 4. For number 9, right after it, same graph, what is the distance the spider traveled from 0 to 8? Remember, we have context here. It's something happened. He traveled, even though he went different directions, he was still traveling a distance, right? So you want to integrate from 0 to 8. You can use geometry shapes. You have a triangle. Then underneath, you have 2 little mini triangles and a rectangle. You want to find all of those areas. But since you know he's traveling that distance still underneath, we're going to keep this whole thing positive. Okay, so the area up top in that triangle is 0 to 4 is 4 over, and then 3 up. So 4 by 3 is 12, but then cut it in half for area of a triangle. That gives you 6. If you do the areas of the under part here, I believe you get 3. And then we said we want to keep them positive in this case because it's still a distance being traveled. 6 and 3 give you 9. Choice C for number 9. You guys have any questions on 8 or 9? Okay. 10. Wants an equation of a line tangent. So tangent line for this. Y is equal to cosine 3x at x equals pi over 6. Anytime you want to write a tangent line, you need a what and a what? Point and tangent slope. How do I find my point? They give me part of it. It says x is pi over 6. Once you get pi over 6 for your x point, the second you have your x point, before you do anything else, you plug it back into the original and see what we get. So if I plug pi over 6 into this original, 3 pi over 6, it's really pi over 2. Cosine of pi over 2 is 0. Now to find my tangent slope, I need to find a derivative. So take this and derive it. We should have this one known off by heart. Cosine 3x, derivative would be not negative.
It's cosine to sine.
You're deriving, you're not integrating. Yeah. Let's try that again. 3 sine 3x. You're right, I'm wrong. All right. And just didn't want to accept it. Okay. Plug your pi over 6 in. What do we get? That'd be pi over 2.
Yeah.
Sine of pi over 2 is 1, and then you make it negative. So negative 3. We want to, what now? We want a tangent line. So y minus y1 equal mx minus x1. And we have this information to plug in. Y minus 0, I'm not going to write it because that's just y, is equal to negative 3 x minus pi over 6. Then take a look at the choices. This is the one, they wrote it in this format. You could easily have seen it multiplied out. And that would be choice, which one is it? A, B, C. Make sense? Okay. Okay, for 11, they give you this graph and they want to know, and it's the graph of the derivative. Want to know which one could be the original. So if I'm looking at the derivative, and this one's nice because they have numbers clearly pointed out here. If you look at the zeros of the derivative, those are your critical points, right? Telling you the maxes and the mins. This one over here is going from positive to negative. Positive to negative tells me I have a what? A max. And then if I'm going over here, negative to positive tells me I have a min. So I'm looking for a max at negative 2 and a min at positive 2. The only graph that does all that is in choice D. Make sense? Okay, we'll just flip this over and keep going. 12. At what point on the graph of, this one is really tricky the way they word it, y equals 1/2 x squared minus 3/2. We want a tangent line parallel to something else. So the first thing I would do is figure out what you want the slope of that tangent line to be, and then you can cross out the second half of this equation. So I'm going to go off to the side. I know that my tangent slope will be the same as whatever the slope is of 4x minus 8y is equal to 5. I want to find this one's slope. Subtract the 4x. Negative 8y is equal to negative 4x. I don't even care about the 5. That's not going to determine the slope, right? Divide by negative 8. Y is equal to positive 4 over 8, positive. So I know I want my tangent slope to be positive 1/2. So this is the tangent line problem the way you guys know it, just going backwards. Normally you have the x value and then you go down. This one's giving you the slope and you're going back up. So I still want a tangent line, so I'm going to say, well, what was the derivative of this? The derivative is, bring that over and I got x, that goes away. Y prime is equal to x. Well, I know what this answer is. I just found it, right? What do I need to make x be to be 1/2? 1/2. You just plug it right back in. So I know now that I have my point is, we're coming on that, and I know my tangent slope is 1/2. So for my point, I know the x value is 1/2. So now take a second and step back and say, what would I do if this problem was just given to me like this? My point is that x equals 1/2. And here's some equation. Find the tangent line. The first thing you would do is plug 1/2 into the what? Into the original, right? Because this is where it gets confusing when you're going backwards. Like a lot of people were plugging it into the derivative. If you were given this from the start, you would find this other half of the point by plugging into the original. So you want to plug 1/2 back into the original equation. So if I say 1/2, 1/2 squared is a fourth, minus 3 over 2 is 1/8 minus 3 over 2, common denominator, gives you negative 11 over 8. What happened to what? I mean, we could have kept going with this. The only thing that equation served was telling me what the slope is going to be. So the y-intercept isn't changing that slope. The slope's going to be the number in front of x. You could have easily just kept, plus 5, and it would have been divided by 4, so 5/4. But that doesn't change the slope at all. Make sense? Yep.
Unrelated, like, I understand what you're doing there, but
I'm recording video, Christos.
what?
You're like 13 says, let f be a function defined by, all we know is here's a derivative. The derivative is equal to the absolute value of some stuff over x minus 3. Do I care what's in between this absolute value stuff up top? No, because I just know that it's going to be what? It's going to be something positive, right? No matter what I plug in there, as long as it's not 3, because it's 9 minus x squared, I know I'm going to get a positive number, right? Okay. So what's the question asked? Let f be a function defined by all real numbers, f prime of x is this. F is decreasing where? Well, what do you know about the first derivative? If the first derivative is positive, that means your original function is increasing, right? It'd have a positive slope. If your first derivative is negative, then the original function would be decreasing. This thing says, find where the original f is decreasing. In other words, this whole question says, where is this stuff negative, this first derivative? So start thinking about numbers you can plug in. No matter what, the top's positive. If I plug in 10, I have some positive thing over what? 7. That's positive. If I plug in 5, still positive. 4, still positive. If I plug in 3, it all blows up. The bottom 0, can't do that. What if I plug in 2? Now that's negative. If I plug in 1, that's negative. 0, that's you can go on forever, right? So anything that's smaller than 3, all the way down to as small as you want, negative infinity. So from negative infinity to 3, and notice the rounded brackets, that's not or equal to, that's just less than that number, right? So this is the way of saying everything below 3. Does that make sense? 14, so we're not going to write this all out, but it says f, there's a lot of words here. F is a differentiable function such that f of 5 is equal to 3. Let's stop there. F of 5 is equal to 3. That tells me right away what? F of 5, normally it's f of x, right? So I just let x be equal to 5, and it gave me a resulting y value of 3. So now I have that point. Let's keep reading. If tangent line to the graph at x equals 5, so what's the next thing they give me? F prime of 5. Notice it's at the same spot, right? They're both at 5. And they say that's equal to 2. So f prime at that same spot, now I have a tangent slope of 2. Okay, now I have a point, now I have a slope. If the tangent line at the graph of x equals 5 is used to approximate, find the approximation of the 0, that approximation is. Okay, translation. All that's saying is find the equation of the tangent line and approximate. We don't even really need to approximate. You can find exactly where it would be 0. So point slope tangent line is y minus 3 is equal to 2x minus 5. Y minus 3 is equal to 2x minus 10. Add 3 over. 2x minus 7. There's my tangent line, and I want to set it equal to 0. 0 is equal to 2x minus 7. Add the 7, divide by 2. You get 7/2, and I think they were using decimals, so 3.5. For 15, the graph of the function is shown. We want to know which one of these is true. Okay. Looking at choice A, says, is the limit as x approaches A the same as the limit that x approaches B? Well, what do I know about B? Is there even a limit at B? No, because what do you need for a limit? The limit from the left has to equal the limit from the right. So if I'm looking at B, there is no limit there. So A is gone. How about choice B? That one ends up being the right answer because it's 4, but let's look at why the other ones are wrong. You can approach that hole in the graph. You never quite get there for choice B, but you get super, super close to 4. So for choice B, that is correct. C is wrong because it says the limit as x approaches B. We just said there is no limit at B, right? That has to be wrong. Same for D. There is no limit at B. And then E contradicts our correct answer. It said the limit doesn't exist, but we just said the limit does exist. So for number 15, you're looking for choice B. Just turn here and 16. The area enclosed by these two things. So we have y is equal to x squared plus 2. Y is equal to 11. area enclosed. Does it give us any bounds? We don't have bounds, right?
No.
So you know this is a top curve minus bottom curve question for integrating, but we don't have bounds yet, so to find the bounds we set things equal. So x squared plus 2 is equal to 11, x squared is equal to 9, x is equal to plus or minus 3. Now we have bounds. So which one of these is my top curve? Which one would be my bottom?
3. Oh, wait.
3's our bounds.
Yeah. Sorry.
11, right? 'Cause 11 is a line. You can't see my hands on this thing. Let's try that again. 11 would be up there, right? And then you know x squared plus 2, 1, 2. That looks something like that, right? So we want to do the top curve, which is this line, minus the bottom curve, which is the parabola, and we just found our bounds for plus and minus 3. So you would want to say the integral from negative 3 to 3, 11, minus the integral negative 3 to 3, x squared plus 2, dx on these. 11 turns into
11x.
11x from negative 3 to 3 minus, this would be x to the third over 3 plus 2x from negative 3 to 3. The hard part, I think, in this problem is plugging in, because you get a lot of double negatives here. You have to be careful. If I plug in 3, I've got 33 minus, when I plug in negative 3, I've got negative 33. So let's bracket that all off. That's that part. Minus, what do we get over here? Plug in 3. What do we got? 3 to the third is 27. Over 3 is 9. 9 and 6 is 15. Minus, what do we get? Negative 3 in here gives me negative 9 minus 6 is a negative 15. So let's do some simplifying. 33 minus a negative 33, double negative plus gives me 66 minus 30 is 36, and 36 is choice C. Number 17. If x squared equals 25 minus y squared, asks us to find, what does that say? What does that mean? D squared y over x squared. What is that?
Dx
Yeah, I mean, what does it ask you to find? What is this? This is the
is
second derivative. Okay, find the second derivative at 3 comma 4. So you could just start doing this. You might recognize this is the equation of a circle and bring everything in a format that's more familiar. Don't have to, but I'm going to say this is x squared plus y squared is equal to 25. Now I'm looking at a circle. We want to find the second derivative, so I should find the first derivative. This is implicit differentiation, so x squared goes to 2x. Anything with a y, we dy dx it, and the 25 is going to be gone. I want to get dy dx by itself, so subtract 2x, 2y, dy dx is equal to negative 2x, dy dx is equal to, I'm going to divide by that 2y and cancel out, so negative x over y is dy dx. I'm going to put a box around it because we've done some of these before, and you know when you take the second derivative you get dy dx's and we have to plug stuff in. So how do I find the second derivative? Need a quotient rule. So bottom times the derivative of the top. What is the derivative of the top? Negative 1. Bottom times the derivative of the top minus top, negative x, times the derivative of the bottom is just 1 dy dx all over,
y squared.
what's my bottom? Y squared. Okay. So, and it's at this point here, right? X, y. So I'm going to say this, let's do a little simplifying first. This is negative y minus minus is a plus x dy dx over y squared. All right, so let's go back to dy dx first. If I plug in 3 and 4, what do I get? This is really negative 3 over 4. Agree? So negative y is negative 4 plus x is 3 times negative 3/4 over y squared. 4 squared is 16. This is negative 4. 3, think of that as 3 over 1, right? So that's negative 9 over 4 over 16. Let's put that 4 over 1. So if I want to subtract these up top, I need to make that 1 a what?
4.
A 4, which makes this top number a 16, a negative 16, right? Negative 16 minus 9 gives me what?
Negative 25.
Negative 25 over 4 over 16. Let's put that 16 over 1 as well. And then we can do that. We're familiar with those arrows. So this is what? Negative 25 over 64. And that was choice
No.
A, right? Negative 1, yeah. Choice A, negative 25/64. Any questions? Good? 18. Integral pi over 4 to pi over 2. Up top is negative e. Cotangent x. On the bottom is sine squared x and dx. Anytime you see one of these and you got trig stuff on the bottom, you're going to want to split this up and then do some manipulating first before you try to integrate. So I'm going to say this is the integral of 1 over sine squared times negative e to the cotangent x. And 1 over sine squared, if I flip it up, would really give me what? Cosecant squared x negative e to the cotangent x dx. And now I'm going to try my u substitution. So I'm going to let u be equal to cotangent x. That would make du equal to negative cosecant squared x dx. Makes dx equal to du over negative cosecant squared x. Take this and plug in. Integral of cosecant squared x negative e to the u dx is du over negative cosecant squared x. So I can take this negative out from right here, but I can also take it out from right there. So if I take out two negatives, those are going to cancel, right? So this is really, and what else do we see? Cosecant squared and cosecant squared, so that really tells me my substitution was good. E to the u du. And again, we took two negatives out, which is why they canceled. If I integrate e to the u, I get e to the u, and u in this case is cotangent x. So this result is e to the cotangent x. It's not plus c, we have bounds, even though I stopped copying them, from pi over 2 to pi over 4. So this problem really is e raised to the cotangent of pi over 2 minus e raised to the cotangent of pi over 4. So now we need to do unit circle stuff. I have pi over 2 and I have pi over 4. Think about your ordered pairs. At pi over 2, it's what? 0, 1. And at pi over 4, the matching root 2 over 2's. All right, and I'm doing cotangents. Cotangent, well, tangent is sine divided by cosine, makes cotangent flip-flop, right? Cosine divided by sine. So at pi over 2, cosine divided by sine, 0 divided by 1 is 0. So cotangent at pi over 2 is 0. So this is e to the 0 minus pi over 4. These pairs are the same. So this divided by that, it's going to be 1. Anything to the 0 is 1. This is 1 minus e. Questions? Okay. 19. So it asks for the natural log of 1 minus x squared, and then it asks for find f prime of x. What do we know about natural log? Derivative is, as we learned it, stuff prime over stuff. Stuff prime gives me negative 2x. over 1 minus x squared. Choice B. Number 19, no, it's number 20. Number 20.
21.
No, 20.
We're doing the same one over again.
Doing the same one. All right. Average value. What do we know about average value? As soon as you see average value, it is 1 over b minus a integral f of x dx. They ask us to find the average value for negative sine x dx from -2 to 4. And I know that tells me to put a 1/6 out front because b minus a gives me my 1/6. Okay, so we integrate. And when you integrate sine, if it was just sine, sine would give you negative cosine. When I have negative negative, so we can say that this is cosine x from -2 to 4, and there's a 1/6 on the outside. So when we plug these in, cosine of 4 minus cosine of -2 all over the 1/6, so we throw a 6 on the bottom. This is what we just talked about in class. An identity back from trig. If I said, because none of these are choices, if you look at the 5 choices, none of them give you a -2 for a choice. So if you look at, let's just say, I don't know, pi over 4, its cosine value would be what? Root 2 over 2. If you look at its identity down below at negative pi over 4, this one has the same exact root 2 over 2. So pretty much by a trig identity, you can say that this right here is the same thing as just saying positive 2, cosine of 2, giving you choice E. (21) Limit as x approaches 1 natural log over 3x. So we'll always try to do what when you have a limit? First objective is see, can I plug in? If it doesn't make the bottom 0, good to go. If I plug this in, I've got natural log 1 over 3. Natural log of 1 means log E1. E to what power is 1? 0. 0 over 3, 0. Choice A. All right, number 22. You want to find where this interval is increasing. So f of x is equal to x squared minus 15 e to the negative x. Underline them, product rule. We want to find out where it's increasing, so we need to set the derivative to 0. This is first times the derivative of the second plus the second derivative the other way around, and then e to the negative x. You keep it. Factor out e to the negative x. E to the negative x leaves me, and there's a negative out here, so let's just pull that out to here. And that leaves me negative x squared plus 15 plus 2x. Again, I'm going to pull a negative out from here. So this is negative e to the negative x. X squared minus 2x minus 15. We're setting it to 0. This e term out here can't be set to 0. We're going to factor the inner here. This is x and x, 5 and 3. And this is negative, positive. Setting these to 0 is negative 3 and 5. Number line. 5, negative 3. So pick some numbers that fit. This would be 0, 10, negative 10. Okay, and we're going to plug these into our derivative. Okay. If I plug in 0, what do we end up with here? E to the 0 is 1, but then this is negative 1, so this is a negative 1 times, and we plug in 0 here, I've got another negative, right? So that is positive. If I plug in 10, 10 gives me 100, that's a positive, that becomes negative, right? We plug in negative 10, that's still 100. That's a positive times a negative gives me a negative. And this problem says, where is this thing increasing? So it increases from, looks like the interval here, negative 3 to 5, and that would be choice D. Okay, for 23, got a whole bunch of words. If the region enclosed by the y-axis, line y equals 2, and the curve y is equal to the cube root of x, let's get that down because that's our curve. Y is equal to the cube root of x. What's the key word here? It's being rotated about the which axis? The y-axis. So as soon as you see y-axis, you know you have to do what with this equation? Solve it for x. So raise both sides to the third, and this is really x is equal to y to the third. This is our equation we're going to be working with. So what do I know my bounds are? It's at y equals 2, and then I'm going to go through the bottom of that being 0. So you're really going from 0 to 2 with this graph, right? So if we know the formula, it would be integral 0 to 2, put a pi out front. The volume with respect to y, or in terms of y here, y to the third. What do we do with our function? We square it, good, and then it's with respect to y. Okay, so now we just do the math. Y to the third squared, it gives me y to the sixth. So in here is really y to the sixth, and then I integrate it, and this gives me y to the seventh over 7, and bring our pi in from 0 to 2. If I plug in 2 to the 7th is 128 pi over 7, and then minus 0, which does nothing. Choice E. $25. The integral of x sine x squared dx. Notice there's no bounds. You know it's going to end in plus c. So what do we do to integrate this? Pick a u. What are we picking? All right, so I'm going to say let u be equal to x squared. Makes du equal to 2x dx. Means dx is equal to du over 2x. Coming back up, I have x sine x squared, but we're going to let this be what now? U, and then dx is du over 2x. You know you're in good shape because the x's are going to cancel. And then I have a 2 on the bottom. 2 on the bottom tells me to pull out what? 1/2. Good. Leaves me 1/2 sine of u du. We integrate. Sine goes to negative cosine. So this is negative 1/2 cosine u, but u is x squared plus c. Gives me choice A. Good?
Yep.
Next one. 26. F of x is equal to the limit as h approaches 0. You have to know what this whole spiel means. What is this? This means what in English? What is this? The what? It's a difference quotient, but this is back in pre-calc. So what did we find out? When difference quotient was before we had a limit, before we knew what that was. Now that I know what a limit is, this whole thing is math jargon for what? The derivative. So remember the original before we try to translate this one. It was f of x plus h minus f of x all over h. So we're saying that's what the original used to be, right? So this right here is your original function, right? This being the derivative of that, what value do I need to plug in to get 4? Done. Okay, for 27, they give you the piecewise function f of x is equal to, in brackets, 3x squared minus 5 when x is less than or equal to 1. it gives you 6x minus plus, 2, where x is greater than 1. So, and it asks you one of those, which one is true things, and you have a whole bunch of choices, but you can see some of your choices also involve the derivative. Personally, I like seeing things. I like anything I can graph, and it helps me wrap my head around it, right? So I'm going to try to graph f first off. So if I graph f, if it's greater than or equal to 1, so here's 1, I have 6x plus 2. Well, at 1, what would this be? 6 times 1 is what? 6 plus 2 is 8, but it doesn't include it, so it's open dot, and we're just sketching. So there's 6x plus 2, right? That line. And if it's less than or equal to 1, I have this quadratic that's going that way. Does that graph make sense? That's the graph of f. Question, is it continuous here?
No.
We don't have continuity at 1, right? That's important. So now let's take a look at the derivative. If I want f prime of x, well, let's just derive both of these. 3x squared minus 5 is what? 6x. And this one would go down to 6. So this is for x less than 1 and x greater than 1. Why did I not include the or equal sign here? Because it's not continuous at 1, so you're on your own to drop the or equal to from that. And here's why this is important. Look how this graph works out. It's really tricky, the graph they give you. So at 1, what do we have? The graph is 6. That was easy. But if you had not dropped the or equal to, look at what the graph of 6x looks like. How does that go? It goes from 0 and it goes up 6 over 1, right? It crashes right through the open dot. My point being is if you didn't drop the or equal to sign, all of a sudden you would have shaded this dot in, right? And if that dot is shaded in, look how that changes your choices. So now let's look at the 3 choices they give you. Choice 1, limit as x approaches 1, f of x. So for f of x's graph over here, do I have a limit at 1? No, they have to match coming from left and right. They don't. All right, so choice 1's gone. That's easy. Choice 2, limit as x approaches 1 for the derivative exists. Well, here's my derivative graph. Forget about everything else. Do I have a limit here? Sure, you can approach the whole. 2's good. But now, if you did not drop that equal sign, this would be a shaded dot. F prime of 1 exists. As it stands right now, does it exist? No, but if I had shaded it in, would it exist? It would certainly look that way, but it wouldn't be correct. Does that make sense? So the choice is 2 only, B. But I could definitely see how you ended up with D if you had shaded that dot in, but the correct answer is B. Yep.
How did you know to drop the?
So you look back to the original graph, and for something to be differentiable, it's got to be continuous, right? So I'm looking at 1 right here, and I know that continuity doesn't exist in here because I have a hole and a gap here, right? So there's no continuity. So that tells me that when I go to the derivative, they can't be the same thing. They couldn't. The continuity didn't let you have differentiability there. So you're not going to have a derivative at x equals 1. It's going to be undefined because it wasn't continuous. Tricky, but for sure eliminate 1. You know 2 is definitely good. And then we've got to think our way through why number 3 is not holding up. All right, last one, number 28. Let g of x equal d dx 0 to x t squared plus 9 dt. If I'm deriving an integral, what do we do here? Remember the way if this was something that was above x, remember how we did the chain rule thing? So this one's just telling me to do what? It wants me to find g of negative 4. This whole thing is just telling me to plug in negative 4, the derivative and the integral are going to wash. I plug in negative 4. Negative 4 squared is 16 and 9, 5. All done. Do you guys have any questions you want me to repeat from 1 to 28 here? Okay.